So when we talk about velocity, see, you guys already know what is velocity. Velocity is basically displacement by time, correct? So in this case, see, just now you guys learned about how motion in one dimension actually happens. It's basically the small displacement what we talk about, the delta r, correct? So that means in this velocity, when we talk about displacement by time taken, now, so pay attention, because when we talk about displacement and time taken, it's actually the delta r value, the displacement. And when we say time taken, see, when we say time taken, it has to be from one point to another point. What is the time I'm taking to travel, correct? That is the time taken. Now, see, now what we'll do is we'll consider a very small displacement and a very small time taken. So we call that value as delta r and delta t. Okay, so we call these values as infinitesimal. Infinitesimal is very small. So a very small displacement delta r is happening in a very small time, that is delta t. So my velocity v becomes delta r by delta t, correct? So now coming to delta r value. See, delta r, basically when r, the position vector r, this was basically xi plus yj, and r dash was x dash I plus y dash j, right? Now delta r is basically r dash minus r. Now if you go to this, we'll get x dash I plus y dash j minus of xi plus yj, right? So you will get this as x dash minus x into I plus y dash minus y into j. Now that x dash minus x, that is how we define delta x, correct? So you get delta x into I plus delta y into j. Now this is your delta r value, correct? Delta r value. Now, so velocity was given to be delta r by delta t, correct? So if you substitute this, we'll get this as delta xi plus delta yj divided by delta t. So which is the same as telling delta x by delta t into I plus delta y by delta t into j, right? Now what we do is, see, we take something known as limit. Okay, now limit, you guys have not studied limit as of now. Okay, so with this example, I'll explain what is limits also. So what we do is we take limit, that is limit as delta t tends to 0. So if you apply that, you will get this as dx by dt into I cap plus dy by dt into j cap. Now dx and dy, dx by dt and dy by dt, we call it as vx into I plus vy into j. Okay, so this is your velocity. Okay, now come back to the limits. So I told we take the limit as delta t tends to 0, right? Now see, look at the graphs whatever is just given. Okay, now in a very small amount of t, right? So this is my first position and this is my second position. See, from first to second, that is from p to q, the delta t value is quite long, it's quite large. Next, look at the second graph, it's a little closer. Next, it's a little closer. Now look at this, the last one. How is it going? It's the same point, correct? Meaning, what we are trying to explain is, as delta t becomes smaller and smaller and smaller and smaller, more accurate result we are going to get. Okay, that's why we call this as instantaneous velocity. Meaning, at that particular instant, what is the velocity of the body? Okay, so as delta t tends to 0, then delta x by delta t, we write it as dx by dt. Okay, now this is something known as differentiation. So differentiation you will be learning this year and next year. So as of now, just know that as limit as delta t tends to 0, delta x by delta t becomes dx by dt. Okay, so my velocity v becomes dx by dt into I cap plus dy by dt into j cap. Okay, so dx by dt is Vx and then dy by dt is Vy. Now if you look at the figure, so you'll get V value is equal to root of Vx square plus Vy square, just like how we did for vectors. Okay, so tan theta is Vy by Vx, so theta is equal to tan inverse of Vy by Vx. Okay, now this gives me velocity. So basically what we say is the change in the displacement, correct? So V is equal to delta R by delta T. Here only if you can take the limit as delta T tends to 0, we'll get V is equal to dr by dt. Okay, so the rate of change of displacement gives you velocity. Okay, understood what is velocity? So in the next video you will be learning about acceleration.